Part number 5, the shaft. And this one, once again, we're going to revolve this one. So I'm going to start with a sketch. I think I want to put it on my XY plane. Yes, right there. And once again, we'll do a center line to help with our dimensioning. And I'm going to go ahead and draw this one out 134 because that's the length of the shaft. Okay, just make it easier later. Okay, now let's turn center line off. And we will draw one side of the profile of this thing so it comes up, and then it comes over, and then it goes up, and over, and up again, over, and down. Whoop. I didn't get long enough there, so let me put a perpendicular right here. All right, and now we will dimension this thing by the book. We've got diameter, and we've got a length of that, length to there, and then of course an overall length, which is 134. So get those dimensions fixed up and then we'll be back. I apologize, this dimension here was not a baseline, it was just a continuous. So I got those done. Now we will finish this and do a revolve and an OK there. All right, now we're going to come back into that same plane and we're going to do a sketch down here. Let's do the threads first. How about that? Let's do the chamfer and then the threads. So we've got a chamfer on this end that is 1.5 by 45 degrees. Right there. Okay. And then we're going to apply a thread on this surface here. And you can see the thread stops at 24 millimeters back. So we're going to go thread, and we're going to select that surface, and it picks up the diameter of the shaft, okay, being at a 16 millimeter diameter. So it applies that. And you can see I already put in the numbers here from where I did it before, because if you measure from this plane down to the end, you got, I think it's 37.5. That's 39. So to that ring would be 37.5. And that's kind of where the thread is going to come from. And so I just subtracted the length, subtracted that 24 measurement out of it. And we don't need an offset. Offset would be how far back it would start from a certain point. Okay. And so there's our thread. Next, we're going to do the Woodruff key. And before I actually start it, you need to grab your textbook and turn back in the appendix. Let's see. It's appendix A66. I'm going to go ahead and start my sketch. On the XY plane. I'm going to go ahead and start it, and then I'm going to explain what's in this table. Okay, so a Woodruff key is kind of a semicircle key. It's not a full semicircle, but it's close. And the diagram at the top shows you how the dimensions work. We are looking for a number 406 key, which has a nominal size of 1/8 inch thick with a diameter of 3/4 of an inch. Okay, And so the other columns there gives you the actual length of the key, and then the height of it. Okay, the height of the key. So we're going to sketch it, but all these numbers are in inches, so we can mathematically convert them to millimeters. You can use a conversion calculator to do that, or you can multiply the decimal equivalent of that fraction by 25.4. That would give you the millimeters, or you can let Inventor do it for you. So I'm going to start with a circle. I'm going to draw it up here. And I know it's just going to be easier if I just place it. Okay. I'm going to come in here with a dimension. I know that this circle should be a diameter of 3/4 of an inch, or 0.75 inches. So if I were to take my calculator that I've got in my hand here and say 0.75 times 25.4, that tells me it's 19.05 millimeters. So I could type 19.05 in. Or I could come in here and say 0.75 inch in lowercase. And now it will put in inches. Okay. It's as simple as that. So I shall measure 19.05 diameter. How about that? Isn't that sweet? Okay, now for the height of it, you see it has a dimension E. I'm looking in the textbook. Dimension E is the height from the center of the circle down to the top of the key, or the key slot. Ooh, wait a minute. I'm having to think right now. Because that is the size of the key. Do I need the slot to be that deep? I'm thinking. Let me pause just a moment. Okay, I apologize. I had a startling realization. The dimensions in the textbook are the size of the key itself. We need the size of the key slot because the top of the key has to stick up above it. All right. So we know that it's supposed to stick up, what was it, 1.7? That's on the edges. We're just going to have to experiment a little bit. So, all right, I'm going to, I tell you what, I'm going to change my dimensioning back so we can see what we're doing, because this is a little bizarre circumstance here. Okay, so I know that this should be 11 millimeters back. So all right, and if I use the dimension from the appendix, that dimension E, from the center of this to here, that's going to make it too low. But I'm going to go ahead and put that in. I need a projected geometry there. And dimension E was 1/16 of an inch. Okay. So now then, if I cut and revolve this, or if I cut this out, then I put a Woodruff key in there, the key would totally go down inside the part. Checking, I went and pulled my copy, my own personal copy of the Machinery Handbook. And if you will have the chance to experience the Machinery Handbook in your 1111 class, it is some wonderful, exciting reading that will keep you riveted late at night with all of its charts and tables and everything. And it says that the bottom of this cut to the top of the edge of the cylinder over on the side should be 0.2455 inches. But if I do that, if I do the 0.2455 here, it'll be too deep still because that measurement needs to come from the edge over there. So let's go ahead and finish this and extrude. Let's go ahead and extrude this. It's the bottom I need, and I'm going symmetrical, and it's 1/8 of an inch. Symmetrical 1/8 inch. What? I didn't choose cut, huh? Okay. Now let's pull, let's go with a half section view. And let's pull back to about the midpoint of that. That looks kind of close to the midpoint. It'll be close enough for what I want to do. So I want to measure there to there. And it didn't measure it. I want the measurement of that edge right there. I'm having a difficult time with this. Okay, I'm going to pause. A good way to test these things when you're having difficulties is to just go to a drawing, and I'm just going to pop in a regular drawing here. I didn't save my part here, so let's dump in that. Go ahead and save it. Okay. Vid 1439-5. Because sometimes you need to look at things and you can't really get a good view of them. All right. So I'm going to do that. And I want to put a section view. Right through there. Okay. Now I can measure things. And let's change our precision up a little bit. Precision, I'm going to take it to 4. All right. Now my Machinery Handbook says that the depth of that, let me get my handy dandy unit converter calculator out here. I don't want. Don't you just hate it when you open an app and you get an advertisement? All right, 0.2455. That was what I wrote down, right? Yes. And let's convert that to millimeters, which gives me 6.2357. Gotta get my pencil and write this down. So right now I have 7.7784, And I want 6.2357. So I do the math. So it gives me 1.5427. That needs to come up. So now I go back over here and let's edit the sketch. And here I have 1.5. Dimension properties. Let's bump that up to 4 since that's what I'm dealing with on my other stuffs. All right, so I want to add these two values together. So I had 1/16 inch. I wonder if this will add millimeters and inches together. Let's see. 1.5427 millimeters. What do you know? 3.1302. All right, we're going to hold with that dimension. I have a test assembly going over on the other side. Let me just do it. 3.1302, writing it down. All right, so here's my test assembly, and it's got a Woodruff key in it already. I'm going to edit that shaft, edit sketch, plus 1.5427 millimeters. Yes, that's kind of what it should look like. That's the way it should look. The Woodruff key should set up above that. Okay, so yes to all, okay. Oh, got to hit okay, duh. So I'm going to go back to my drawing here and bring in another base view since I've got that assembly, test assembly, yes, okay. And let's pop a section on it, section. Dimension, that point, 1.71. Because remember we have 1.7 in our cut through the keyway that we made. Let's bump our precision up here and see. 0.7145. That'd be a tight fit, but that's like, 4/1000ths of a millimeter. Yeah. So we need to drop that down. A little bit more. So let's drop it down 45/1000ths of a millimeter. Let me do it on my test here first. So I know this is getting to be a long video, but this is it's a learning opportunity for you. And by golly, when you go to work somewhere, this is a lot of how you're going to do it. You're just going to play with things until you can figure out what works. So I need to drop that down 45/1000ths of a millimeter. So I'm going to say minus 0.0045 millimeter. And update. And save. Go back to here. Hey, hey, hey. I love it. I love it when it comes together. Isn't that what Hannibal and Mr. T used to say? I love it when a plan comes together. All right, so now we know what that depth should be. Ooh, thank you very much. So that height should be 3.126. I'm going to check that anyway, so that I've got 4 decimal places, and we'll go with the the regular number instead of the math. Well, maybe the 1/16 plus 1.5427 minus 0.0045. Okay, so that's what we will put in back over right here. So let's edit that sketch. And let me just go ahead and subtract out the 0.045 there. 427 minus 0.0045 makes that to be 1.5382. Awesome. Okay, so that is a Woodruff key slot. Now we got a couple more holes to put down here, one of which is an NPT threaded hole. And I don't think you've run across NPTs yet, but we can model them with our hole command. We go with a tapered hole right here. And NPT is National Pipe Thread. Okay, and they're actually tapered. They're not like a bolt thread. Okay, they actually taper so that as you thread the pipe into the fitting tighter, the farther into the fitting, the tighter it gets. And the threads are based on a set diameter of pipe, basically. Okay. All right, let me get back to my textbook here where I can see. And so we know it's a 1/8 inch NPT. It has a termination depth. It's not a through all. Excuse me. It has a distance depth. And my drill depth is 44. All that looks good. So we'll come here and make it concentric and go OK. Now you see the threads only go in so far, and the distance the threads go are based on the diameter of the thread. And it has a standard, Inventor gives it a standard diameter drilled hole, which is not exactly what's shown in the textbook. We're just going to go with what the standard Inventor one is. Now, we have a hole that goes through here. It's an oiling hole. And so we can do a sketch on the plane that is perpendicular to our Woodruff key, right here, the XZ plane. And it's a small circle that is, what is it, 8.3 diameter. And it is located 12 millimeters from here. And it is, I'll try horizontal. I'm not sure that that's going to work. Let's see. Yeah, awesome. Fully constrained. Extrude that both ways through all. Cut. There we go. And there's our part. I don't think we got, yeah, I don't see no chamfers or anything like that. It's called a shaft, and it is a cold rolled steel, which is the way it's manufactured. So we will come down here and just use steel. Ooh, not steel plate. That's ugly. We'll use steel polished. Yes, that looks mighty nice. All right. And put the name of the thing in the iProperty, save it as your 1439-5.